Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week, 1 week not 1 week early, 1 day early. And today we're going to be talking about percentiles, and during the daily weather update I talk a lot on the ensemble precipitation forecast about the 25th, 50th, and 75th percentiles. And when all three are lit up, I have much higher confidence that it's going to rain during that time period. You may be asking yourself, well, what the heck does that mean? Well, the reason we use ensembles in the first place is that we cannot observe the atmosphere perfectly, even with all the surface weather stations, the weather balloons, the radars, the satellites. There are still things that we miss, and they're not big, but they're still there, okay? So one of the advantages of using ensembles is that we take the analysis and we tweak it just a little bit to 30 different extents. And these are very, very minute tweaks, but they're still there. And then we run all 30 members out in time, 4, 5, 6, 7 days. And if all the solutions are tightly packed or similar, then that gives us high confidence in the forecast. It says the atmosphere really doesn't care if there's a small error at the beginning or not. But if 4, 5, 6, 7 days out, it looks like a finger painting exercise with one solution there, one here, and one down there, then that tells you that the atmosphere is very sensitive to those minute changes at the beginning and that the forecast confidence gets increasingly low as you head out in time. So instead of relying on one model, what we call a deterministic model, and putting all your eggs in that basket, isn't it a better idea to run all the ensemble members with slightly different analyses to see how sensitive the atmosphere is to those changes, and so you can then convey to the public your level of certainty or uncertainty in the forecast? And so that's what we're talking about. The percentiles basically tell us what the probability is of certain thresholds being exceeded during a certain time period. And so that's what we're going to talk about today, and I hope I can do this without being mean. I hope you get that pun. All right, so consider this. We have 61 students taking a test. Now, the low score is 35, the high score is 95, and the average score is 65. The 25th percentile means that there is a 25% probability of a given test score being below that value, or a 75% probability of it being above that value. The 75th percentile means there's a 75% probability of a given test score being below that value, or a 25% probability of it being above that value. So let's look at a typical bell curve, and the test scores are along the bottom, along the x-axis, and let's split this up into several different parts. Now, the 25th percentile turns out to be a score of 50, which means there's a 25% chance in all these test scores that the test score is going to be below 50 for a given student. The 50th percentile is right in the middle at 65, so there's a 50-50 chance of the score being above that value or below it. And the 75th percentile means there's a 75% chance of it being below that value, or a 25% chance of it being above that value. When you shade in the area between the 25th and the 75th percentile, it basically is giving you that middle 50% of the pack, okay? If you're below the 25th or above the 75th, those are considered to be outliers. Now, you can make a good argument, and I may consider changing my approach here, is that 10 and 90 would be a better way to look at this, because if there's a less than 10% chance of something happening, that really is quite small. A 25% chance of something happening is not negligible. I mean, when you remember the forecast in the summertime, when you hear a 30% chance of an afternoon thunderstorm, it gets your attention, okay? So I might want to rethink this, but for the purpose of this example, and since we've been doing it this way, we're going to stick with 25 and 75 for now. So these areas would be the low outliers, these would be the high outliers, and the middle 50% in the middle of the curve is right in here. So last but not least, consider these facts. The scores above the 75th and below the 25th, we're going to consider outliers, okay? They're much less likely than being in the middle. But outliers are not impossible, as shown by the fact that some of the students did indeed score below 50 and above 80. So less likely, but not impossible. The 50th percentile is not necessarily equal to the average or the mean. Sometimes you can have a couple of extreme outliers that are so far separated from the pack that they distort the mean or the average either higher or lower. And this is one of the advantages to using percentiles, because it sort of corrects for that. It doesn't allow those couple of weird values to change your thinking about the overall setup. But basically, it tells you where most of the values are and where the highest probabilities of something occurring are. So that is why we look at percentiles a lot more than we look at means or averages. All right. That's bonus weather video number 1 for this week, one day early. I hope some of that made sense. The next bonus weather video, if I stick on schedule, will be Friday, and the next daily weather update, of course, will be coming up late tomorrow afternoon. Hope you will join us for any or all of the above of those entities. In the meantime, have a great Monday evening, and we will talk to you again late tomorrow afternoon. Take care, everybody.